All right, welcome back, everybody. This is Unit 1, PowerPoint Slides Part 4, Video 7, I believe. I promise we're getting close to the end of this section of PowerPoint Slides. All right, so let's look at an example question. Take a moment and read this one. All right, make sure you jot down your answer. If you have a buddy, go ahead and pause the video and discuss it with your buddy. Okay, so this one's referring to temperature. We just had the previous one to refer to temperature also. In this case, our temperature gets colder, right? So remember our standard value of room temperature is about 70-ish degrees. So we're talking about a cold winter day, so maybe it's 15 degrees outside. Our temperature is slower. What happens to our speed when temperature gets slower? Okay, it's gonna go slower. So colder temperature, slower velocity. Our velocity is smaller, then our frequency has to also be smaller. So the answer in this one is A, less than 50 hertz. Okay, let's take a look at another example. Apparently I'm missing this one too, so we'll do it on paper. Okay, so we know we have two instruments. Okay, take a moment and read this one and make yourself a picture of what this looks like. Okay, so go through and figure what we have. It gives us the length of the flute being 66 centimeters. I'm just going to call it L sub C. And it gives us the length of the flute, which I call L sub F. And it tells us our speed. What are we looking for? Okay, so we're looking for the frequency of the lowest note. And the next highest. Okay, so let's switch that over to the document camera so you can see this. So we said the length of our clarinet was 66 centimeters. The length of our flute was 63.6. And our velocity said it was a little bit warm day, so it's going to be slightly larger. And so we want to know the frequency of the lowest. The next one, so we're looking for which values of M. We want F sub 1 and lowercase f sub 2, right? For each thing. So the first thing we got to figure out is what do these look like? Which one is open? Clarinet or a flute? Okay, our flute is going to be open. Okay, our clarinet is going to be open, closed. Okay, let's start with our flute first. F1 for our flute, for open, is going to be V over 2L. Okay, we know our velocity told us was 350 meters per second divided by 2 times our length. Now, our length is going to be in centimeters, and we want it in which system? We want it in meters, good. So that's going to be 63.6 Centimeters is 10 to the negative 2, so times 10 to the negative 2 meters. So we're going to have 63.6 times 10 to the negative 2 meters. And go ahead and throw that in your calculator. I got 275 hertz. For my frequency of my the fundamental frequency of my flute. Now my clarinet, on the other hand, F1, is going to be B over 4L instead of 2L. So this one we're going to have 350 meters per second divided by 2 times our length of 66. Now instead of being 66 centimeters, we want 66 meters. 66 times 10 to the negative 2 meters. So do your unit conversions. Go ahead and work that one out. When you're ready, restart the video. I got 133 hertz. So you notice the clarinet is about the same length as a flute, but your fundamental frequency is about half of what your flute is. Okay, so now let's find the next one higher. So we want to find M2. So we know that F2 is just equal to M times F1, which is going to be 2 times F1. So for our flute, F2 is going to equal our 275 hertz times 2, which is going to give us 550 hertz. Our clarinet, on the other hand, F2 is going to be 133 hertz times 2, which is going to give us 266 hertz. All right. Questions here? If I want to find our, whoops, sorry, let me cut that out. If I want to find F3, I just take 3 times F1. By F4, it should be 4 times F1. So if you know your fundamental, you can then calculate any other value you want. All right, I think this brings us pretty much to the end. Oh, sorry, a little bit more. We're almost to the end. So your string instruments work this way. You've got strings that you create tension and fix them both ends. You can calculate, I don't know if it's the notes you heard Printer talk about this already, but if you know your velocity, calculate your fundamental frequency, and then from there, you can calculate any others. Wind instruments, same thing. You have your frequencies, depending on whether it's open, such as a flute, or open, closed, and you find higher harmonics. So you can do things like overblowing instrument, produce higher harmonics within it. So, all right, and we're not about loudness yet, so we're going to skip this slide for now. And that brings us to the end of this thing. All right. So this is going to be the end of part 4. Part 5 will be a bit briefer. We're going to pick up concepts of loudness of sound, and we're going to pick up Doppler effect. What happens to sound, what happens to waves as they move. And that will bring us to the end of this unit. All right, well, thank you very much, guys. Please let me know if you have questions. Please use the discussion boards and the chat features built into the class. Let's all work together to get this stuff figured out.